So you need to accelerate, basically do more computation, and you need to reduce the cost. So our focus is whenever those models are trained and they know what to do, we take them to make them run as fast as possible and to lower the costs associated to that.
Welcome to FLAT Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Hader. In this episode, we'll explore the growing trend of AI on the edge and its implications for the IoT industry. My guest today is Ludovic Larzul, CEO of Mipsology, and he will help us separate the hype from the reality and explain to us how AI on the edge changes data collection, processing, and analysis in real-time applications. We'll discuss the benefits and challenges and look ahead at the future. I'm really happy to have you on the show, Ludo. Thank you for being here. How are you today?
I'm doing good. Thank you for having us.
My pleasure. Maybe to kick us off, would you like the chance to introduce yourself and Mipsology?
Yes, let me do that quickly. So my name is Ludovic Larzul. I'm French, living in California. I'm the founder and CEO of Mipsology. At Mipsology, we are doing AI for real world. We are focusing on computing the neural networks to produce data as fast as possible. So basically, if you want to go one level higher, we are taking a lot of numbers, billions of them, crunching them, and we produce an information that a human would understand.
Interesting. Mipsology provides FPGA-based solutions for deep learning inference. For those of you who may not be familiar with the term, FPGA stands for Field Programmable Gate Array. Those powerful integrated circuits can be configured and programmed to perform complex computing tasks. And in the case of Mipsology, they are using this technology to bring the power of deep learning to the edge. Can you explain a little bit what the concept of that is?
Yeah, so there are two big phases in AI. The first phase is learning. You take a huge amount of data and you are modeling those data in a neural network. And a neural network it's doing very basic operation. We are focusing on the next step, which is once this model has learned to recognize a little cat or to produce a sentence that makes sense or things like that, you want to put that in the hands of the few billion people on Earth. Mm-hmm. And that's yet another problem, because if you take, for example, ChatGPT, 175 billion parameters, that means that you have even more computation than that. So it's 1,000 billion. I'm keeping billion trillion, 1,000 trillion, because that's in mind, that's already a very big number, but imagine 1,000 times a big number. So it's really, really high. But for each and every user, you have to compute it again and again and again. So that means that the scale of that is way larger. And so the problem there is to be able to deploy those models. You cannot really keep those models to be so big, because the cost of running each of them, that is too high. So you need to accelerate, basically do more computation, and you need to reduce the cost. Mm-hmm. So our focus is whenever those models are trained and they know what to do, we take them to make them run as fast as possible and to lower the costs associated to that.
And I think also the core of your product, or what your flagship product Zebra is doing, it's running these inference models on FPGAs.
Yes, so FPGAs are programmable components.
Yes.
And they are not very well known to the vast majority of people, but they are in everybody's life every day.
Okay. Can you give an example?
Yeah, as soon as you use a mobile phone, there is an FPGA somewhere, and the somewhere is actually the base station. When you use internet, there are FPGAs in the infrastructure of internet. When NASA sends something anywhere, either a satellite or a rover on Mars, most likely there is an FPGA in it. All the rovers on Mars have FPGA in them. So those components are very flexible, but they're professional components. You will not find them today in your computer. Their big advantage compared to a CPU that everybody knows is that when we program them at the level of hardware.
Mm-hmm.
A CPU, you will do step 1, step 2, step 3. It's kind of order. In an FPGA, you will, if you have 1,000 steps to do, you do 1,000 steps at the same time. Everything is in parallel. So they are extremely powerful. However, they are very complex to program.
Okay.
So that's our specialty, is to be able to program those components. And we did specialize those components to compute neural networks.
And what are the benefits of this?
The obvious benefit is the more powerful is the component, the more you can do computation. And at similar cost, you will reduce the price of deploying an application. If you want to deploy an application at the edge, particularly for millions or billions of people, you need to pay attention to the cost. So if you divide by 2 the cost of something at the scale of millions of people, it is really a lot of money. If I take one application, for example, if you take an automotive application, for example, we are talking about millions of cars. You cannot decently put, for example, a GPU, which is one of the favorite components for AI in every car, because the cost of GPU would make the car cost go much higher. Mm-hmm. So you have to reduce that cost to be able to deploy AI. This is one of the main challenges today. If you think about it, so there is this hype about ChatGPT. There are some hypes about image. There are some hypes about each domain has their own hypes. But those hypes are based on research. Mm-hmm. Once the hype has passed, it's not like you can use directly this AI the day after. The reason why fundamentally is the cost of deploying is very high. So our focus is to make that cost lower. And because those components are pretty hard to use, we make them look like simple. That's our job. So people using our technology, they don't have to think about the FPGA. We do the same, but for AI.
You just mentioned self-driving cars as a use case. Do you have any other use cases you could share with our listeners?
Yeah, today, that's what is interesting with AI. That really goes everywhere. I've been amazed over the last more than 5 years now to see how people want to use AI. And when we say AI, I use AI not in the hype sense. I use AI in the sense how you can apply AI to problems that will help people every day. And not in 10 years. I'm talking about shorter term. So self-driving car, very interesting problem, but it's pretty easy to find some counterexample. And this is a question of safety. You cannot decently trust an AI to drive a car today. Some situation, yes, not every time. So we focus on some more concrete problem. For example, that's last week, there is a project to detect fire and smoke based on cameras to be able to have early alerts when there are fires in forests. And that is today, that's something that can be done as soon as possible because the technology is ready for that. But again, you have a problem of deployment. If you want to monitor very large forests, a lot of cameras, a lot of hardware, the cost goes high very fast. So we are looking at that from a point of view of, can we lower the cost drastically so it can be deployed everywhere?
Interesting.
Medical is very active. There are some people working with neural network to recognize cancers way better than a doctor. It doesn't mean that the AI will do it alone. We are not going to remove doctors. It's more like the AI will look at images and say yes, no, perhaps.
You said AI is better at detecting cancer?
Yes. Based on image, doctors are very good and I would trust them more than AI. But a doctor can be tired. A doctor may not have the time. They may have only 1 minute to look at an image and have something in their mind because they will have a surgery. So it's human nature to have trouble focusing.
Okay.
So AI will be able to detect on images cancer more efficiently than the doctor. Now, to be very clear, the AI will not decide, but the AI can reduce the amount of work of the doctor, and the doctor will have to look at the image because sometimes the image will have a glitch. There will be some kind of weird stuff in the image. Maybe the doctor will say, yeah, that image, I mean, even so it says there is a cancer, maybe the doctor will say, no, the image was not taken properly. You have to go back and take another one. So the doctor is there to kind of triage, but the AI does the first job of saying, no, obviously there is no cancer. Obviously there are cancer. And sometimes, I don't know. Doctor, tell me. So those things there are already very good progress on that, and that can be deployed tomorrow. There are some, the process of medical things can be pretty long, but the technology works. Surveillance, like detection of intrusion, detection of flood in buildings. Very simply, entering a garage lot to take a picture of the plate and recognize with that. All those applications basically are pretty much ready today. They work. However, to deploy them, we're going back to that. If you want to deploy automatic recognition of plates in garages, there are millions of garages. So you need to have that system deployed on a very large scale. Mm-hmm. If you want to put security in buildings, you have millions of buildings. So all those things are really about scalability.
Okay.
That's where we are looking at.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or afnet-silica.com. That's avnet-silica.com. Where do you see this landscape evolving in the next couple of years, next 5 years?
AI progress will continue. One of the limitations that I am concerned about is there is probably a lack of focus on doing some models that are of reasonable size. Let me try to explain that. To be able to deploy to everybody, you need the models to be of a number of computation that is not too high.
Okay.
Because the more multiplication, the more addition you do, the higher cost you get. And today, when I look at models, they are always growing. And ChatGPT is great, but 175 trillion parameters is crazy. And this is potentially a limitation because the higher it gets, the less progress you get. So you need to continue to scale that to a level where there is a kind of competition between the progress of AI and the progress of the chips in terms of training. And there is a point where one will limit the other. Today, there is a kind of race, and that is scaling not exactly nicely, but good enough, let's say. There is a point where chips cannot go as fast as AI. AI is really a permanent revolution. Doing a silicon chip takes 2 years, 18 months at best. So there is this kind of race that can limit AI. There will be progress, for sure. We will continue to see things. ChatGPT will look like a toy in 5 to 10 years. In the same way as what we were doing 5 years ago looks like a toy today. And even so, you don't realize, and you have AI already in your life every day, you will get way more AI, more visible AI. The deployment will accelerate. That's where we are today. We are at the point where deployment is accelerating. We are seeing more and more people who want to use the current state of the art of AI to be able to deploy in the next few years.
It's really interesting because next to the hype, there's always all the discussion about ethical implications, transparency. Your sale will be all around us. What do you think is the most important factor in driving adoption and success for artificial intelligence solutions?
So definitely the ethic part is a concern. Even so, we are looking at deployments. So for us, I would say it's not a problem in reality because when we start working, the model has been trained. So we have to trust the people who have trained that model to do something that it follows good ethics.
Can you summarize the success factors? So you said transparency, and of course it has to be ethical, and then trust the system. And then what are the most important factors in driving?
And then price. It's all come back to price. Everybody is sensitive to price. The price of those models today is high when you look at each iteration. So you need to find an economic model for each of them that makes sense. Okay. It doesn't make sense to put $5,000-$10,000 of silicon in a car for a self-driving car because you don't really offer that to everybody. If you want to offer that to everybody, you need to lower the price. If you want to deploy in all buildings, you have to lower the price. If you want to apply AI to all medical field, you have to lower the price. So past all those things, which are, by the way, also a little bit hype, the reality of deploying AI comes back to what's the cost. That's the ultimate limitation. You can have the best technology. If you cannot deploy it, it stays a science project.
Also on the show with us today is Robert Lara, Senior Marketing Director at Mipsology.
Thank you, Ruth.
What would your advice be for companies who are interested in leveraging AI technology in their business?
Yeah, to answer your question in terms of what companies should consider from the engagements that we've been involved in, I would say shorten your learning time by working with experts. We at Mipsology, we're really proud of our subject matter expertise in AI, and we partner with an ecosystem like Avnet Silica. So the bottom line is there's so many things to consider when building, deploying, and considering maintaining an AI solution. So it's the old, measure twice but cut once metaphor. And we suggest doing this with industry experts who can provide the full suite of services and solutions that are required for success.
Makes sense. So what would your advice for companies be?
Integrate the cost of deploying when you start. We have seen pretty not high number of time, but we have seen some people coming with, I've solved my problem, my neural network works. But they've never thought about how they're going to deploy that. They want to deploy at a given cost, and that simply is not possible. And that's not just us, that's globally speaking, that's not possible. So I would say when you look at deploying AI, which is really our focus, it would be great that people integrate that factor when they start doing the research on the problems they want to solve. You can scale a model, you can do very, very big models like ChatGPT. But deploying them is very hard. I know Microsoft works very hard on that right now. The cost of deploying that is probably very big. They haven't published any number, but we are talking probably of hundreds of millions of dollars to deploy that. Now think that if that would be 10 times smaller, would everybody today already interact with ChatGPT? Most likely, yes, because 10 times cheaper means that's an investment that is more reasonable for a company like Microsoft. When you scale to some models that are smaller, like garage, medical, and so on, the same. If you divide by 10 the cost, then you diffuse that technology way faster. So my advice to anybody is, great, you have a problem, you want to solve that with AI, be sure you can solve that with AI. Once you know you can solve that with AI, integrate the fact you want to deploy that.
Terrific. Ludo, Robert, thank you so much. It was really great talking to you today. Thank you so much for your time. This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.